Chapter 2. AI Training. AI training revolves around remembering the relationships between samples and their respective labels. When AI confronts new data, it utilizes these learned connections to assign the suitable label. To enrich AI recognition capabilities, as depicted in this figure, I adopt two main strategies. Firstly, to broaden the recognition scope, I expand existing labels by incorporating more samples. Secondly, for gradual recognition, I introduce multilevel labels derived from the recognition path. Chapter 2-1. Gradual Recognition Design. My recognition design aimed to train AI for detailed and gradual recognition of each sample. Instead of using a single AI to assign each sample with either a single label or multiple labels, as shown in this figure, I chose to utilize multiple AIs to assign each sample with labels at different levels, as illustrated in this figure. Chapter 2-2. Multiple AIs. I designed multiple AIs at 3 different levels by assigning 3 labels to a single sample, as seen in the right diagram of this figure. The following are the reasons for employing multiple AIs instead of relying on a single AI. Chapter 2-1. Multiple AIs Training. Training multiple AIs for samples enhances efficiency and saves time. Unlike a single AI, which would need to learn each sample 3 times for each label, multiple AIs enable each level AI to learn each sample for each label once concurrently, as illustrated in this figure. Chapter 2-2. Multiple AIs Gradual Recognition. This approach enables gradual recognition, as each recognized outcome progresses from higher to lower levels. Notably, partial recognition is feasible, as shown in this figure, when recognition is uncertain at the parent level and further recognition is halted. The final recognition remains valid up to the grandparent level, which is labeled as vehicle. Chapter 2-3. Flexible Label Adaptation. Multiple AIs facilitate flexible AI label adaptation. Similar to infants learning new words, multiple AIs continuously incorporate undefined labels from user samples. For instance, as illustrated in this figure, after multiple AIs trained on labels like vehicle, Fiat, and 500, they encounter a sample labeled vehicle, Fiat, and 124. Then, they recognize this sample only up to the label vehicle and Fiat. To adapt with this new label, 124 at level C, as seen in this figure, the multiple AIs undergoes retraining this sample with the specific label vehicle, Fiat, and 124 at level A, B, and C, respectively. Multiple AIs are effective in adapting additional labels to predefined labels, akin to how humans distinguish concepts, more specifically, prioritize certain concepts, or exclude others from recognition. For example, in the case of refining a predefined label, as depicted in this figure, the 3-level label system encompasses the recognition of vehicle Fiat 500. To delve deeper into specific details about the Fiat 500, AI level D can be introduced to handle vehicle model years as labels at that level. For example, in the case of prioritizing predefined labels, as depicted in this figure. Prioritizing the recognition of specific labels within Level A can be achieved by integrating the selected labels as newly defined ones at Level 0.